So the quotient rule is different from the product rule, and that's different again from the sum and difference rules, right? So let's just rewrite the product rule again. So, sorry, if h of x is the product of two functions, f and g, that means h prime of x is f prime g plus g prime f. What about h prime of x, f of x over g of x? So here's what we're gonna do. I'm not gonna first principles it, although you could. The first principles proof is on Wikipedia if you were interested in using that. Let me unplug and plug in my... So the proof for this using first principles is on Wikipedia if you wanna like give that a read. I'm just gonna use the product rule. So let's rearrange it. So I'm gonna multiply both sides by g of x. So it's f of x equals h of x, g of x. Then using the product rule to take the derivative, we have f prime of x equals h prime of x, g of x plus g prime of x, h of x. Here's the thing, we wanted to solve for h prime of x. All right, so isolate h prime because that's what we want. At the end of this scenario, we want a formula for h prime. So let's isolate for h prime. So move all the terms first by addition or subtraction, then you can divide. So g prime of x, h of x equals h prime of x, g of x. And then divide them both by g of x. So h prime of x, I'm gonna rotate the equation. H prime of x is f prime of x minus g prime of x, h of x, all over g of x. But this is kind of like recursive. There's my programmer ways again. I don't want another h of x in there, right? Let's break that down because I just want my formula to have f and g. So let's rewrite h of x to say f and g. So h prime of x equals f prime of x minus g prime of x. And then h of x would be f over g all over. All right, so it's getting all crazy with the fractions again, right? So let's do a common denominator. So f prime of x minus g prime of x, f of x over. All right, so multiply top and bottom of this f prime of x by g of x, so we have a common denominator. So f prime of x, g of x over g of x. I haven't really, again, changed much. I just gave it a common denominator. Multiply top and bottom by g of x minus g prime of x, g of x. That's what we got so far. I'm going to zoom out a little bit so you guys can see all the steps leading up. All right, so that's what we had so far. So we use the product rule. We isolated for h prime of x. When you isolate for h prime, you still have an h of x. So I replaced the h of x with the original fraction. And that's what we're doing right now. We're just sort of playing around with the fraction. I'm going to try and finish this up in one line. So two steps in one line. So that's why I moved my h prime of x over here. F prime of x, g of x minus g prime of x, f of x over g of x over g of x. If you recall with the triple fraction thing going on here, it's basically this divided by that. So if I'm dividing this entire piece by g of x, I'm actually multiplying by 1 over gx. So my final formula will be f prime of x, g of x minus g prime of x, f of x all over g of x squared. You might notice it's different from the product rule in a number of different ways. I'm going to scroll back up. So my product rule is over here. And as you can see, it's a sum, right? The resulting derivative from product rule is a sum, whereas in quotient rule, it's like a difference with a denominator underneath. So it's different. Like the order matters for this one. So you got to do the f prime first and then the g, and then the g prime first and then the f. When I'm going to go back on the review sheet here, here's how I'll write it down. I usually write it down as n of x to stand for numerator. And I'll say d of x for denominator. And that helps me keep track of what goes first and which goes where. So it's numerator prime denominator minus denominator prime numerator all over denominator squared. All right, so let's do some examples just using our quotient rule. The equation of the tangent to h of x, 3x minus 4 over x squared plus 5 at, let's try x equals 2 and see what happens. So recall, if I plug in 2 to the original function, I get the point. And if I plug it into the derivative, it gives you the slope. You put it into your point slope formula, and then you're done. So it is a rational expression. It's a fraction. So we will have to use our quotient rule. So I'm going to use numerator and denominator to help us keep track. So my numerator is 3x minus 4. My denominator is x squared plus 5. So that means the derivative of my numerator is 3. And the derivative of my denominator is 2x. So here's the pieces I need. We're going to put them together using the quotient rule. So let me rewrite what the quotient rule is. So h prime of x is numerator prime times denominator minus denominator prime times numerator, everything divided by the square of my denominator. So we have 3 x squared plus 5 minus 2x, 3x minus 4. So you end up with a similar scenario from product rule, right? Like if you arrange them correctly, you should see each one of these 4 things represented, right? So you double check. I didn't duplicate one of these things, right? My denominator will be different. It's x squared plus 5 all squared. Okay, and now let's simplify. We could either simplify, I kind of want to simplify just for fun, and then we'll plug in a 2 when we feel like it. So numerator is going to be 3x squared plus 15 minus 6x squared plus 8x over. I'm not going to simplify the denominator here, because I'm thinking long term. I'm thinking if I can plug in the 2 there, it'll be very straightforward to just solve. If I expand it, it's more work for me. Whereas the top here, I'm going to clean it up a little bit before I plug in a 2. So we end up with negative 3x squared plus 8x plus 15. And then I think that's where we'll stop simplifying. Zoom out so you see the whole thing. So if I plug in h prime of 2, which again gives me my slope, I should get negative 3, 2 squared, plus 8, 2, plus 15, all over. 2 squared plus 5 squared, so that should be 4, plus 5 on the inside, squared. So negative 3 times 4 is negative 12, plus 16, plus 15, all over. 4 plus 5 is 9. 9 squared is 81. It's not going to give you a clean answer. It's basically just 19 over 81. Therefore, equation of tangent will be y minus, what's the point we got up top there? Oh, we didn't plug it into the original function yet. Okay. So h of 2. So we should have plugged it in first. I don't know why I didn't do that. 3, 2 plus 4. 2 squared plus 5. 6 plus 4 is 10. 4 plus 5 is 9, so 10 over 9. Is my screen glitching out? Yeah, it is. So the equation of my tangent is y minus 10 over 9 equals 19 over 81, x minus 2. And again, like I said, you guys have enough to worry about right now. Like you can just, if I do an equation of tangent question, just leave it at this. It's fine with me. dy over dx. Yes, there it is again, right? So in this, the notation says that y is the name of my function and x is the name of my variable. So that's what that is, right? Function, variable. Let's break this down again into numerator and denominator. N equals 2x. D equals x squared plus 1. dn over dx. We're going to get in big trouble here. dn over dx is 2. There it is. Huh, that's funny. Over dx is 2x. That's fine.
So now dy over dx using the quotient rule in Leibniz notation is the numerator prime times the denominator subtracted by derivative of the denominator multiplied to the numerator all over denominator squared. Just a little bit more awkward. The numerator prime is 2 multiplied to the denominator subtracted to the denominator prime times the numerator, all divided by my denominator squared, so x squared plus 1 squared. Let's expand the denominator here. 2x squared plus 2 minus 4x squared all over x to power 4 plus 2x squared plus 1. Calculus in itself, it's fairly straightforward, right? Like we're given all these rules, but half of it is doing the algebra, right? Like most of these questions are pretty much just algebra once you apply the rule, right? Like simplifying, multiplying, making sure you don't miss a step. So it's really important that that side of your math needs to be on point. And again, comes with practice. Last example, we'll just go back to prime notation. So now I have my numerator, which is 2x plus 8. My denominator, which is root x. My numerator prime is just 2. And my denominator prime will be 1 over 2 root x. And again, I can jump from here to here because I know I've you sort of do it enough times, you start seeing it. Let's use the quotient rule. So f prime of x. I'm gonna write the quotient rule every single time because it's a long one, and you don't want to miss a thing because it's like a really long one, right? Like, and prime of x is 2. D of x is root x minus d prime of x is 1 over 2 root x. Numerator is 2x plus 8. All over d squared. All right, so in this example, the denominator is actually cleaner. It's going to end up with a cleaner look than in previous examples when we simplify. Here we go. All right, again, I'm going to simplify all the way with this. I think with questions like these, I will expect you guys to give as simplified answers as you can, like fully expanded. If it's factored and it's stuff that are in brackets here, it doesn't count as simplified. So when you get to here, make sure you start simplifying. So I see a fraction there. There's a couple things we can do. I'm going to do a common denominator. That's 2 root x times another 2 root x minus 2x plus 8 all over 2 root x all over x. So here's what we're going to do. We're going to simplify. Again, this is the numerator, and I'm going to divide it by that at the end of it. Something to keep in mind. So 2 root x times 2 root x should be 4x. 2 times 2 is 4. Root x times root x is x. 4x minus 2x plus 8 all over 2 root x times x. Sorry, divided by x. So you end up with 2x plus 8 over 2 root x over x. That's going to be fun. 2x plus 8 all over 2x root x. In this example, I missed the minus sign again. Not to worry. And again, we can keep going. Let me show you how. We factor out the 2 to get x minus 4 over 2 x root x. Divide both the 2's out. And my final answer is x minus 4 over x root x. And that's my final answer. How do you get the bottom x root x? Great question. Let's take a look. So from here to here, that's breaking down the fraction again, right? It's like this is my numerator. That's the denominator. So this divided by this is the same thing as multiplying by my reciprocal, like so. So if I go 2x minus 8, it's 2x root x, like that. It really takes a lot of getting used to seeing that double fraction divide like